In the last video, I discussed about measurements. Now, today we are going to discuss about one-dimensional kinematics or motion along a straight line. So, before going into the topic, let us understand what is kinematics. Kinematics is the study of the motion of objects. It does not study the cause of the motion. The study of the cause of motion is called dynamics. So today we are going to learn about speed, velocity, acceleration, 5 equations of motion, and much more. So let's begin. When I say that something or someone is moving, then is it moving for everyone? Consider a pen in a table. Now the table is not moving and the pen is also at rest. But if an astronaut looks at the pen, obviously he won't be able to see it. But if he does, then he will see that the pen is moving along with the earth as the earth is rotating. So who is right? Both of them are correct in their own way, in their way. Motion has no meaning if you don't say with respect to whom. With respect to you, the pen is stationary. But with respect to the astronaut in space, the Earth is moving as the Earth is spinning on its axis. This is, this is what we call the point of view or the frame of reference. For the frame of reference of the astronaut, the pen is moving as the Earth is spinning. And for your frame of reference, the pen is at rest. So motion is relative. There is nothing like absolute motion. Distance traveled is something which we all might know. But now we are going to discuss about displacement and distance. When we say that something moved at some distance, then do we need to give the direction along with the magnitude? No, as the distance is a quantity which has only magnitude and no direction. This type of quantity is called a scalar quantity. A vector also has magnitude just like scalars, but it also has a direction. Displacement is a vector quantity which tells the shortest distance between 2 points along with the direction. Here the vector is the displacement of the object, and this arrow is the displacement vector of the object. We will discuss about vectors in more detail in the next video of physics. Now, how do we write how fast an object is moving using mathematics? The speed of an object is the measure of how fast an object is moving. Now, more distance an object covers in small amount of time, the faster the object will be moving, right? So the speed of an object can be calculated using the following equation. Now, this quantity is scalar as we don't need to tell the direction of speed and therefore has only magnitude. Now, if we are interested in the displacement covered in a unit time, then we would like to find the velocity of the object. Just like speed is the distance covered per unit time, velocity is the displacement of an object per unit time. Now, the average velocity is easy to calculate. You just need to know the total displacement and the total time, and then you can divide the two. Now, if we want to know the instantaneous velocity or the velocity at a given amount of time, at a given point of time, then we can calculate it using the following equation. dx here is a very small change in x, or a displacement in a given dt, or very small change in time. Now, let us understand this using graphs. First, let us plot the displacement time graph of an object. Now, the velocity is displacement by time, or it is the slope of this graph, right? So, if we want to know the velocity of this object at time equal to 5 seconds, then we can just draw a line which is tangent to this graph at that point in time. Now the instantaneous velocity at 5 seconds will be the slope of this line, which is the following. Now, in real life, most objects do not move at the same velocity, so they change their velocity. Now, the rate at which velocity changes is acceleration. If the velocity of the object does not change with time, then the instantaneous velocity and the average velocity will be the same. This can be shown in a displacement time graph in the following manner. Just like the displacement time graph, we can express acceleration in a velocity time graph, and the slope of this graph is the acceleration. We can also have acceleration time graph where the slope of the graph is the rate at which acceleration changes, and so on. Now, just like displacement, velocity and acceleration are also vectors. Now, if we assume this direction to be positive, then now if we say that an object is having a velocity of negative 5 meters per second, then it means that the object is moving in the negative direction with a velocity of 5 meters per second in the negative direction. Now, if we say that an object's acceleration is negative 5 meters per second squared, then it means that the object's acceleration is 5 meters per second squared in the negative direction. So, if the acceleration of an object is negative, then it doesn't mean that the object's velocity is decreasing. Now, if the sign of the velocity and acceleration are the same in a particular direction, then it means that the velocity is increasing. And if the sign of velocity and acceleration is different, then it means that the velocity is reducing. Now, if we know the average velocity of an object and the amount of time the object traveled at that average velocity, then we can calculate the displacement of the object using basic math. If you want a few examples, then watch this animation. Now, if we have the velocity time graph of a body, then the acceleration of the object will be the slope of the graph, right? But what will be its displacement? First, the velocity of the object of the of the object at an instance of time will be the value of the y coordinate at that point in time. So the displacement is velocity times the time taken for the body. So we can imagine this graph to be made up of very thin rectangles. These rectangles are actually very thin, but I will draw it thick so that we can see all its parts. Now let us focus on one of these rectangles. The area of this rectangle will give us uh, will be the instantaneous velocity times the time taken, which here is very small. So the area of this rectangle is the displacement covered from the start to a point in time. So the total displacement will be the area of all these rectangles, which is the area of this graph. So if the object's velocity time graph is given, then the object's total displacement will be the area of this graph, or the area of the shaded region in this graph. Same thing goes for the acceleration time graph. The average velocity of the object will be the area of the graph, and the slope of the graph will be the rate at which acceleration changes. If the acceleration is constant, then the average velocity will be the following. Now, we can understand this using graphs and a little bit of algebra in the following manner. Now, the average velocity is total displacement divided by total time. So, the total displacement is the area of this graph, which is equal to the following. Now, the average velocity will be the following. This is only true if the acceleration is constant. Now, we will look at the equations of motion which are applicable only for objects which are undergoing constant linear acceleration. So, we can use this equation to derive these equations, as all of them are only applicable for objects which are undergoing constant linear acceleration. Now, first of all, what is acceleration? Acceleration is the rate of change of velocity, or the following. Now we can rearrange this to get the following. This is the first equation of motion. Now, before moving forward, I want to tell you that the displacement will be represented using the following. Now, in this example, you see that the velocity is negative whereas the acceleration is positive. What does this mean? It means that the direction of velocity is opposite to the direction of acceleration. Now, we solve this problem without considering this. What you need to do is assume a direction to be positive and the opposite direction to be negative. Now, if the velocity is negative, then it simply means that the velocity is in the negative direction. When objects fall, then they undergo constant acceleration. But this is just an approximation. But then also we can use the equations of motion for free fall motion. The acceleration due to gravity at the sea level is approximately 9.81 meters per second square. We will discuss about gravitation in my future videos related to physics. Thank you.